before we get started, I need to correct two things. Number one, when determining what percentile a data point is, it's not the position of the data point over the total number of data times 100. It's the position of the data point before it over total number of data times 100. Because you want the percent of data less than your data point. So what I did was less than or equal to it. Second, I think I figured out what was going wrong here. I was trying to set up the classes. So I wrote the test, and I wrote the solutions, and I got it the way I wanted it. So what you want to do is you take your smallest data point and subtract that from your largest data point plus 1. In this case, plus 1 because they're whole numbers. Divide that by how many classes you want. So we said what was the smallest data point here again? 119, wasn't it?
Yeah.
And what was the largest?
168.
160? 176?
Oh, we're
Yeah,
176. Yeah,
176.
176.
So 177 minus 119. All right, 58. And how many data classes do we want? I think it's supposed to be 7. Right? I just went up to 8 or something. Divide by 7. Does give 8.2, round that up to 9. Now, it looks like I won 6, doesn't it? What was this class with? 119 minus. So it would go 119 to 128, then 128 to 137. Seven add 9, 146, 155 to 164, 164 to 173, 173 to 1. With the max being 176, that does cover all the values we want. So the class width would be 9. So that corrects. On to today's stuff. is it? Oh, that's right. This one is weird. This one is weird. This is actually going to be a fairly easy day. Which is both good and bad. First project is this week. Your first test is next week. I'm going to get an extra credit opportunity. We're continuing our study of visualizing data. Another type of graph, I use that term very lightly, it's called a stem and leaf plot. Numbers will get split into a stem part and a leaf part. The stem can be any number of place values, but the leaf can only be one. So if you're dealing with whole numbers, typically we take the leaf to be the units digit, the unitary digit, and then the leaf will be everything else that's responded. Right? So if you have 105, your stem would be 10. Your leaf for that would be 5. If you want to compare two separate data, then a back-to-back stem and leaf plot can be used. You want to use the same leaf values, and then on one side would be, or the same stem values, the one side would be the leaf values of the one data, the other side would be the leaf values of the other. And I have examples.
I have a question. Our test is in here. I can't write. It doesn't want to download.
That's an issue. Can you write with your mouth? Might be a useful skill. We'll see how things go. That's obviously a circumstance beyond your control.
Yeah,
So we're gonna have to make arrangements. Remember that just happened.
It just happened today.
I know. You knew a test was coming. That can't be as bad as what happened to me where I broke my foot the week before my wedding.
Oh my god. That's insane.
That was fun. My story is she pushed me down the stairs to keep me from escaping, and that's So here we have a data set. First exam scores for a pre-calculus class. And they are arranged already for you in ascending order. So we're dealing with all whole numbers. So we take the leaf to be the units. The stem will be everything in front, so the tens and the hundreds. This would be the stem and leaf plot. It does give a nice quick overview of how many 90s did I have. If I count that right, 7. I may not count that right. Don't know. Remember, I had just as many 60s. Three back to back. We have presidential ages at inauguration versus ages of their death. Oh, actually, just
Is that actually their real dates of birth? I mean, deaths?
yeah.
Oh.
This is after death. I did notice I'm missing lines for some reason. I can't be bothered to try and fix that chart. And this actually does now give me an idea of how old this data is, at least. The latest this data could be taken would be 2016. Well, let's say January of 2017 would have been the latest this data would have taken. So then this would be the back-to-back stem and leaf plot. And again, you can look at this and go, okay, well, what was the oldest inauguration age? Giggity. And the oldest death, 93. Youngest death, 46. That's a shame. Who was that? Oh, that's true. That's a shame. That actually is a shame. Who's 49? I'm curious. Can I read this data? Oh, Barclay. It wasn't? There it is.
Yeah.
That was Garfield.
Word.
Other than an orange cat, but that's his own.
Wait, so he died the same day? I mean, the same year?
Oh shit, yeah. He was inaugurated at 49 and died at 49. That's probably why no one knows him. That's okay, we're very morbid. Statisticians are very morbid. And Taft is another one. I don't know what that is. I don't know if that's a good thing or a bad thing. People don't know their presidents. Hmm? He got stuck in his bathroom. Okay, now I have to read up on that because that just sounds hilarious.
Oh, he was assassinated, Garfield.
Really?
Uh-huh, I just looked it up.
Wow. Damn, didn't realize it here. You can. Right, so at which point you pick your leaf to be the very last digit. And the stem would be, well, it's just the very last digit you say. Right, so let's say these are all decimals. It'd be that 10th place. Right, so it's easy to pick the leaf. It's always the last digit. And the stem is everything that's in front of it. But that is not ideal. Right? Stem and leaf plots are not ideal for decimals. Maybe if there's only one decimal place. But after that, it's really not ideal. Right, honestly, I would personally only ever use a stem leaf plot for whole numbers. And even then, just as a quick comparison, I would never actually use it in a serious manner. Grades on the chemistry exam are given. Construct a stem and leaf plot. Again, let's look for the smallest value. So that's where our stem will start 5. What's the largest?
86.
99. So our stem will go down to 9.
99? Oh.
Next line.
Okay.
Look for all of the scores that are in the 50s. Looks like it's just 51. Now, there's not actually a rule that says that your leaf has to be in any kind of order. Right, so you can just go term by term and write them out as you see them. You don't have to worry about writing them in ascending order. Generally, we want to do that. So if you have a computer do it for you, that's how it's going to generate it. It just makes that a little cleaner. What about in the 60s? No, so you just leave the leaf blank.
Yes.
70s.
77.
4.
So what are the scores?
77.
Right, 7, 8, 6, 9. Let's write that in ascending order, even though it's not really.
I just finally got it.
Yeah, that makes sense. Compared to that first one.
So say we did it with and the professor wasn't indicating 6. If we don't put the 6 there, that's.
You have to put the 6
considered
there. You have to put the 6 there.
Okay, so you see how
So
you
the
got
stem
that
can't
6
skip
and
values.
It has to.
So being that they always have that 7 and
So
5,
does
6,
the 10.
Right, which is why you don't want to start with like
The 1 going
0
Yeah, let me look.
to go from 0 to 100. Because you have
explain it to me.
4 or 5.
Before looking it up, I was like,
So you just skip those. So you start with the low. And you go up to the high.
I was lost when I was 10. Oh, no, I knew this, I remember this. Back to back.
The leaf is always the
76, 77, 79.
and then the stem is everything that comes before it.
I don't understand how they got this.
That's why for decimals it's
Oh, yeah,
not.
that's what I see now.
Again, unless it's just to the tenths.
Okay.
Because then you have like 100.8, you have your stem at 100.
5.
Yeah, 5, yeah. And then the next one is 6.
It doesn't matter what it is, behind or in front.
So what about the 80s?
2.
No, it's 3. 1, 2, 3, 4 is
1,
4.
2, 3, 4, 5. 4, yeah.
1, 2, 3, 4, 5.
Yeah, you got it.
Yeah.
There you go.
And what about the 90s?
9.
Just 9.
Does your stem reflect those down?
That's not bad.
Can the whole test just do it?
There is a stem leaf plot on the test. I remember that one.
Can you? No, I was going to ask a dumb question.
So I don't want to say there's no such thing as a dumb question, because there are, contrary to what you've been told, but answer the question.
Because I've been having trouble lately with the homework, to be honest. And so far as the test stuff, I was going to say if we could get a preview or a pre-test or something, so I can take it. You said they got.
Well, we're going to do a review.
Okay.
Yeah.
There is a review posted on Blackboard. If you notice, I hit the solutions, because that's going to be your extra credit. So I'm going to do that with all this stuff.
Please.
However, I don't know where she got the questions from. Didn't provide me that, so I had to use a different test bank to write the test. But it does cover everything we did.
So our homework is not graded?
No.
Okay.
Well, it may be graded, but it's not counted.
Oh, okay.
I think Blackboard does give a grade for it, but it doesn't count towards your final grade.
Once we got to the Z mode and what's all that, I was like,
Z-score?
Z-score? I'm like, oh, no. It was a blank.
You're overthinking Z-score.
It was just,
Value minus mean divided by standard deviation.
so when you say it like that, you know,
That's all it is.
Also,
It gives
use
you like
the
that
tutor.
silver
The
flag.
tutors are good.
Literally
The
just
24/7 tutors, they're really good.
They have it like where it's on the.
Yeah, so
already looked at the
basically, you
slides that
click
you did.
his course,
The
click his course, and then it literally say tutor, and you click it, they're good. I've been using them a lot.
All right, so you really?
That's the first good thing I've heard about the tutors.
Really? The ones I personally, no, if everything's going on, I'm not sure.
so I be trying to look,
so-
the way he explains it
So you
is good.
see, once you
The way
go
she
on,
explained it, I'm saying like, what were his videos at?
you just
Because
click
I'm
the
like,
24/7.
like,
Good, me?
yeah, I'll be trying to.
Yeah, I
look
haven't
for-
taught stat in years, so I don't have lecture videos for that.
I'm trying to look for those though.
They're on there. Just go to the assignment folder.
I always just find hers.
And if you go to the assignment folder, scroll
Yeah.
down. I don't put them in a separate folder, it's just in that specific
And
assignment
then
folder.
just put statistics.
There's always going to be two links, a PDF, which is the slide,
And then-
and then the actual
And
recording
then I
itself.
chat with them,
Thank
because I feel like just type it is more fun than they just talk to you and explain it. So just put chat with voice. And then put your question or take a picture of the image and attach the file.
And the one
Submit.
they show the notes.
It's like a person. So you can do this,
Yeah, I saw that.
yeah, so you click that, and it takes you.
So the next table is going to give percentages of adults who were never married in the 50 U.S.
And then the
states.
question?
Mhm.
We will construct a stem and leaf plot.
Do we look for those numbers? Oh, no. I don't know.
The table, I mean, I could have put the table on that slide, but it's really small. Which is fine for me, because I already have the data. I already have the stem and leaf plot made. Wouldn't have been so nice for you guys. Maybe for your test, I'll make the chart. Give it a monocle or something. So there's the data. So
What
here's
was
your
the,
question.
wait, what was the question one more time?
Percentage of adults in each U.S. state that have never been married.
Okay, thank you.
I think Washington D.C. is also included. So there's 51 data points. So here's decimals. But it's only to the tenths, so that's the decimal point. The decimal value itself will be our leaf.
I see a trend.
What if we don't get a fish no more like this?
It's- No, because that's the right solution. I don't want to make that solution. All right, I'm a solution by hand. I don't necessarily trust the test bank answer. Here. Screen, yes. I'm smart this time. I can save the spreadsheet. So what you'd have to do is obviously enter your data. Now, Excel does not have a STEM plot. It may have an add-on that does it. That I just didn't bother doing it. So enter all of your data. I really only needed C2. I didn't need any of the states. So making a STEM leaf plot of C2. Graph. Now, somewhere. There it is. STEM leaf. Right, obviously 1% unmarried. I think it just did it twice, so let's pretend that's not there. Right, select. Increment of 1, just leave that alone and hit OK. This here, this first column is just giving you a count.
Of how many there are, correct?
Maybe. Thought that's what it was. Maybe not. Now I'm looking at it.
Yeah, because this, I think, goes over to.
No, because 33, it's a 2. I have no idea what that column is, and I don't care. This is your stem, this is your leaf. So they just don't leaf block.
So on the test, we had to write the whole leaf.
How long do we have?
75 minutes. It's doable.
You said?
75. You won't have a large data set like this on the test. All the data sets are manageable.
Are we allowed to use our phone calculator?
Not the phone, no.
So we need to get one.
The phone calculator is not that good. You'll want a scientific at it. Maybe not so much for what we're doing now. No, we getting the probabilities.
I wish I known. I
A
had.
scientific calculator can do a lot
I
of the probability
purchased
stuff for
one,
you.
a scientific calculator.
Ouch.
I wish I known that.
Yeah, no, it's, they'll ask sometimes. Just ask.
I know. That's fine.
Question on 70.
When you had the back-to-back one for the inauguration, was that for the year?
No, their age.
And then you did that.
Yeah. And then the age that they died. So the age when they were inaugurated and the age when they died.
Yeah, that kind of confused me, right? I'm not gonna lie.
Well, actually, why is there no 7 here?
It's just
Be
the
a
whole
7.
line. And the only thing I could do was the left hand. Yeah, the left
Yeah,
hand,
the left,
this
yeah.
one. But that's why I had to go back to that. That makes sense. But It's still the same
So it's
thing.
the
You're
same,
reading
right?
Yeah,
Yeah.
you're just reading it the other way. So
I may
42,
fix that.
43,
There should be a 7.
47, 48,
Right.
49, so on and so forth.
Where they're in the 70s.
Yeah, well. 72, I see 71, 71.
So I'll have to fix that.
One, two,
You must have missed that one.
Either way, it's still a good example.
So if you do that on the test, you can't take points off,
It's like,
because you made the same
it's called
mistake.
instructor's prerogative. Learn from my mistakes. There's one thing left to discuss. And that's the idea of misleading graphs. So I kind of touched on this already. That you can use data to mislead people. The numbers themselves don't lie. So we've already seen that graphs, visual aids, are extremely useful for visualizing your data. However, we can also misuse them to misinterpret data. A lot of the time that is done on purpose. Three of the most common forms of misrepresentation. The most common is an incorrect position of the vertical scale. Incorrect sizing of graphical images. And then a misleading perspective if it's a three-dimensional diagram. As a general rule of thumb, just don't ever use three-dimensional diagrams. How do you represent 3 dimensions on a flat sheet of paper? It's impossible. How many dimensions is our universe?
Infinite. That we know about, I mean, like proven.
Nothing's ever truly proven in science. Or, what would they be?
I know Tom is one. You really want me to name all of them?
You're overthinking. X, Y, and Z. You're 3 spatial and 1 for time. That's for most of physics. That's actually not correct. That's 10 dimensions. That's 9 spatial and the temporal dimension. That is out of string theory. So this leads into what I was saying, you can't represent 3 dimensions on a 2-dimensional sheet of paper. Go ahead, imagine the 4th spatial dimension. You can't, because we're 3-dimensional beings. We have no concept of the fourth dimension. We can't even visualize it. But a four-dimensional being can interact with that world and make things appear like miracles. Think of UFOs. Oh, I'm sorry. UFPs.
Really?
That's what people are. Unidentified flying phenomena. How some of them just seem to disappear without a trace. What if it's not actually disappearing? What if it's just moving up in the fourth dimension and out of our three-dimensional world? I'm going to use your cup as an example. Which means I'm going to steal it from you. So pretend for a minute this table is our world. So we're two-dimensional beings living on this table. Can you see the cup in that world?
Yes.
You'd have to look up in the third dimension, which doesn't exist to you.
Because we are.
Because you're two-dimensional, you have no idea of the third dimension. A circle just appeared out of nowhere. Now, of course, I can't do what I want to do next, but I'd be able to pass through. Right, so now imagine this cup is now passing through the world. The circle would start to get larger. Get to the straw, now it's going to be like really tiny again, and then once it's out in the fourth dimension, it disappears without a trace.
And that's like physically possible? That's crazy.
It's been mathematically proven. We're not actually able to verify it because the amount of energy we need to be able to verify string theory is the Planck energy, which is essentially the total amount of energy in the universe.
That's like quantum theory, quantum and all that stuff.
No, string theory is general relativity and quantum field theory combined. It's the theory of everything. So it's even worse than quantum. If we could harness the fourth dimension, we could have heart surgery without cutting you open. We just work in the fourth dimension. As I said, the most common incorrect position of the vertical scale, meaning your origin is not the actual origin. So whenever you draw a plot, what you would call a graph, it's not actually a graph, graph is something different. And so we don't say we graph x squared, we plot x squared. The horizontal and vertical axes, the x and y, always cross at 0, 0. You can mislead people by not having it cross at 0, 0. You can move the x-axis up or down. In fact, the most common graph that does this is stock markets. If you actually look at the scaling of the stock market graphs, where they cross, it's relatively close to the lowest value to make it appear like there's much larger growth than there really is. So here, average cost of a house per year from 2016 to 2019 is a proper positioning. We start at the origin. So average house cost doesn't seem to have fluctuated that much. Now, let me mislead you. The exact same data. But notice where the origin is now. It crosses at $345,000.
Wait, can you say that one more time?
Say what?
Like what you just said? I'm confused.
What did I just say?
It crosses out whatever.
Oh, where it crosses?
Mm-hmm.
It crosses, look at the right side. $345,000 instead of
Zero.
zero.
Oh, okay.
This makes it look like there's been a drastic jump from 16 to 17.
Okay.
But it wasn't. In actuality, it was less than $50,000 increase in the average home cost.
If it's misleading like that, can someone just automatically see that?
Not if you don't know what to look for. The people who publish this think you're stupid and hope you're stupid and don't know how to read graphs.
So every graph should start at zero. So soon as you see a one, it's
Yeah, if you see anything but the origin being at zero, then they're trying to mislead you. And it works. Advertisers do it all the time.
That's because a lot of people don't look at the side, they just look at the.
But a lot of people also don't know how to read a graph.
Some people just look at the visual, like the bars and stuff, they won't look at it. And the numbers.
That's what they're hoping for. They're hoping you're not statistically literate. But now, you won't fall for that. Hopefully.
isn't that illegal?
Right. What's illegal about it? They're not lying about the numbers. It's just how they're represented. There's nothing illegal about that. Could make an argument that should be. But then who decides what misrepresentation is? Well, actually, I did want to show something. Why is this on this slide? That note's on the slide. But I actually discussed it. Oh, no, it's not. It is on the slide. But I did want to show. So this is pretty standard for stock market graphs. This is obviously just for, wait, why is it not shown? So this is pretty standard for stock market graphs. This is only shown for one day, but you can find graphs that give like 6 month, 1 month, a year, and they're all very similar in the sense. This is where it opened. So you'd look at this and you think, oh my God, there was a massive drop. Or look at the peak. Look at, oh, there was a huge drop. Yeah. Look at the axis.
So the axis doesn't always have to be all left, or it can be left.
It depends on
the graph.
Depends on how you want to draw it out. So opened, whatever, what did it open at? Opened at, looks like 56, 34, 58. Closed at 56, 18, 26, so only a 0.29% drop, which is nothing. Contrary to what that would have you believe.
So that's like, on that graph, are they then saying that it visually drops significantly, just only drops 10% of the area?
It only dropped 0.29% of the opening cost. So it only dropped 16.32. So the stock value only dropped by $16.32. When the stock value itself was over 5,000. So it's not a significant drop.
Unless if you brought it in as an option.
That's a
Like
lot.
the contract's option. Well, you don't know if it's options for with the stock market?
I don't do the stock market. I do mutual funds.
It's like more of a magnified.
That's essentially what you're doing. You're zooming in, so to speak. So what they might want you to do here is think, oh my God, look at the giant increase. I'm going to throw money into it's going up. Or, oh, it dropped so significantly, sell stocks. Wish I had the money. A lot richer right now. And everyone's panicking in the stock market just
It's
blown
better
up.
to buy when it's low.
Especially if
Yeah.
you follow the economy and you know that in 2020 was a false low. I knew by the end of 2020 it was going to go back up to the levels that it started at, which was 4 times the value. So incorrect sizing of graphical images. When amounts are compared by constructing an image, the areas of the images should be proportional to the amounts. So for instance, if one amounts twice as much as the other, then that image should only have twice as much area. Remember, I'm gonna go simple. Rectangle. What's the area of a rectangle? What is it? Length times width. So if I want to double the area, I do not double both length and width. Doing so would quadruple the area. However, that is very common. For something to be twice as much, and all they do is they double both dimensions. Thus quadrupling your area. So quadrupling the size of the image. 1990, the average sale price of a house was $149,800. I paid that just for a plot of land. And that was cheap. In 2020, the average sale was $389,400. If you do the math, it's about 2.6 times. However, that 2020 image has more than 2.6 times the area. So that would be misleading. And finally, like I said, just as a general thumb, don't use three-dimensional diagrams. When a 3D graph is rendered, it is generally done so from the perspective of looking down on it. Which makes the bars appear shorter than they really are. Right, so it's the same data, the 149,800 and the 389,400. But this would kind of look like it's smaller than 149. Because again, how do you render 3 dimensions in a 2-dimensional screen? Or a 2-dimensional report? Right, the only proper way to do that now would be 3D printing. But then you have to actually have the people come to where it is to view it, instead of just printing up a report and publishing. I never use 3-dimensional graphs, except in calculate, but that's okay. Oh, you know. There's really no questions for misleading. Then I guess I could try and find some graphs and ask if it's misleading or not. And so the whole point of that is just to don't be fooled. Now when you look at a graph representing data, actually check it very carefully. Make sure they're not trying to mislead you. Any questions? So quiz 3 will be due next Wednesday. First project is up. It's 2 weeks I gave you to do it, so it'll be due October 2nd. Of course, the most exciting piece of information. First test is next week. That's exciting.
Please,